Hello Year 11, this is your lesson on combinations with restrictions. Okay, so sometimes we'll be asked to find the number of combinations that include specific items. This will reduce both the number of items that we have to select and the number of items from which we are selecting. For example, a hand of cards consists of 5 cards drawn from a normal deck. How many hands contain both red aces? What does this mean then? Okay, so we need to include both the ace of diamonds and the ace of hearts. That means that we only have 3 cards that we need to choose, that we need to select. We've only got 50 cards that we're then selecting them from. So the number of hands would be 50 choose 3, which is 19,600. Pause the video while you have a go at questions 1 to 3. Okay, sometimes it can be more efficient to count the selections that we don't want. For example, I've got to choose a team of 4 from a group of 8 people. Now, Keem and Matt are in this group, but I don't really want them to be in the team because they might distract each other. How many ways can I choose this team? So let's start by thinking how many teams there are altogether. So there's 8 choose 4 ways of selecting a team of 4 from 8 people. Then what I'm going to do is subtract the number of combinations, the number of teams that include both Keem and Matt. So if Keem and Matt are on the team, then there are 2 remaining spaces for students from the 6 students that remain in the group. So that's 6 choose 2 different ways of having teams with Matt and Keem on them. So I take the total number of teams, subtract the number of teams with Keem and Matt, and I get 55. Pause the video now while you have a go at question 4. Okay, sometimes we need to make multiple selections from different groups. If so, we can apply the multiplication principle to find the number of ways of performing each task. So here I have an office, we've got 7 women and 4 men. How many groups of 5 can I make if there are no restrictions? So if there's no restrictions, it doesn't matter how many women or how many men there are, there's just 11 people. So in this case, 11 choose 5, which is 462. If I have to have 3 women and 2 men in my group, then I've got 7 women and I'm choosing 3 of them, and I've got 4 men and I'm choosing 2 of them. I multiply those 2 amounts together, so 7 choose 3 and 4 choose 2, to find the total number of teams. Groups. With at least 1 man, let's interpret that. Well, that means there's going to be 1 or 2 or 3 or 4 men in the group, and any other spaces left need to be filled with women. So that would mean I've got 4 choose 1 times 7, because there's 7 women, choose 4 because there's 4 spaces remaining, plus, because this is one possibility, or I could have 2 men and 3 women, or I could have 3 men and 2 women, or I could have 4 men and 1 woman. Notice here that the 4 and the 7 remain the same all the way along, because I'm choosing the men from a group of 4 and the women from a group of 7. Notice that the R's, the subscripts, they always add up to 5 because I need to have 5 people on the team. So I do this calculation and I get 441. Now, there's a quicker way. It would have been much more efficient in this case to consider the selections that we don't want, i.e., how many teams are there with no men? So 11 choose 5 is the total number of groups. 7 choose 5 are the number of ways I can make a group of just women. So I take away all of the possible groups with just women, and that gives me obviously the same number, 441. So this method is much more efficient, you can see. Pause the video now while you have a go at question 5. Okay, so sometimes we need to combine permutations and combinations by selecting things first and then finding out how many ways there are to arrange them. So in this question, we've got the letters of the word duplicate, and we want to know how many arrangements can we have that have 2 vowels and 3 consonants. So let's start by looking at how many of each we've got. We've got, these are consonants, so 1, 2, 3, 4, 5 consonants. Let's write this down. So I've got 5 consonants, it doesn't matter what they are. And I've got 1, 2, 3, 4 vowels. I'm looking for arrangements of 2 vowels and 3 consonants. That's going to be 5 letter arrangements altogether. Now, I've got 4 choose 2 ways of selecting 2 vowels. I've got 4 vowels, I want to choose 2 of them. I've got 5 choose 3 ways of selecting the 3 consonants from the 5 that are available. So the number of ways of arranging them I can calculate is 5 factorial. So the total number of arrangements is 4 choose 2 times 5 choose 3 times 5 factorial, which is 7,200. Okay, so now you can finish the remaining questions 6 to 15 from exercise 7F. Make sure you're checking your answers as you go and ask your teacher if you have any questions. Thank you.